Hello students, welcome back. Radical equations. Please brace for impact. This is going to be really long and difficult. Now, how important are they? Well, there are a lot of equally as important but easier types of problems out there. Therefore, it is relatively rare that I pick up radical equations as exam problems or something significant. But there were semesters that I did, and of course, I do not exclude anything. I kind of randomize, and some semesters I use radical equations, some semesters I don't. It's just that it's compared with its difficulty, the importance may not be as much as the difficulty. Let's just stop there. So if you're on an A in this course, want to cover everything like blanket, of course you should know. If you're in B in this course and then want to have a certain proficiency, you should study it to a certain degree. And if your goal is barely passing and still barely making, in that case, you may have to make a little bit more strategic choice, going over a little bit easier topics like complex numbers or inequalities and those kind of things. Okay, all right. Radical equations. Radical equation, remember two keys. Number one, whenever you have radical isolated, take the power and then radical is gone. Usually we're going to be using square root because that's the easiest computation. No other use, as a matter of fact. And then if you have cubing root, then you have to take cube of the right hand side, and then that's already complicated computation. If you have sixth root, now the right hand side to the sixth power, you can do that kind of computation. So most of the time you're going to get square root equation, but the idea is the same. Isolate the radical and then take power, and that'll remove the radical. But there's a bit of a catch. These two are not equivalent. So this blue equation may generate green equation, but solution of green equation does not necessarily give you the solution of blue equation. So whenever you get some solutions here, it's very important you go back to the original and check those. And you may have some fake solution, which we call extraneous solutions. Well, too much theory. Let's actually go to an example problem. Okay, let's begin with something relatively simple. So this kind of equation, flip this 2 to the other side and then write like this. And then we simply take the third power. If I take the third power, well, nobody will actually write like this, but I'm using computers, so I can easily take copy and paste. So let's do this. And cubing root and cube cancel out. We have 2x minus 4, and the right hand side 2 to the third power. That's what you're going to get. Of course, everybody will jump from here to there directly, or at least 2 to the third power, and then calculate it into 8. Now it's easy. Flip this 4 to the other side. Is equal to 8 plus 4, which is 12. So dividing by 2, x is equal to 6. Is that a solution? Well, it's tempting to stop here, but make sure you go back and check your solution. Is that a solution? Check that. What do you get? This is 2 times 6. That's 12 minus 4. So what do you get? No, never mind. Let's copy and paste one more step. 12 minus 4 is 8. cubing root of 8, so 2 minus 2 equals to 0. Okay, so that's a solution. Alright, that wasn't too bad. But this is not exam worthy. Okay, here we go. If you take square of left hand side, do you get this? Excuse me, I didn't want to copy entire problem. Okay, alright, square. Okay, let's take square. And square root cancel out, so this becomes just 2x plus 3, right? And then square root cancel out, so we get x plus 2. And then that's 4. And does it working okay? Actually, no, this is bad. I made a critical mistake. A minus b squared is not equal to a squared minus b squared. It doesn't work like this. This is wrong. A minus b squared is equals to a squared minus 2ab plus b squared. This is the right way. Now, if you square this, square root will be gone. Great. If you square that, square root will be gone. So this part and that part is okay. Now, minus 2ab, you have to multiply these two square roots, and square root is not going away. It's just that it became worse nightmare, even worse square root. Clearly this is not working. So it doesn't work. How do we do that? We must isolate the radical as before. Isolate radical as before and then square both sides, or previously took cube of both sides. So let's isolate the square root. Square of the 2x plus 3 is equals to 2 was there before, and then flip this to the other side. This should be your starting point. And then take square of both sides. Right? Now this square root will be gone. Square and square root cancel each other out. And here, let's see how it works. Square and square root cancel out, we get 2x plus 3 from the left hand side. Good. Right hand side, you have to square this, 2 squared. And then you have to square that. Square and square root gone. Oh boy. Looking good. Or not. Yes or not. Didn't work out. What did I just do? I did this. A plus b squared is a squared plus b squared. That's what I just did. That's not true. So I did this squared plus that squared. So this is bad. No, it doesn't work this way. How do I make it right? Plus 2ab. Now we have equality. Complete square formula. Where is? So we need this. So let's put this one in. Plus 2 times 2, because this 2, times square root of x plus 2. Oops. Sorry, I clicked the wrong key. X plus 2 And that's how you handle. Let me emphasize this part in red from the complete square formula. Do you get it? Left hand side squared, so getting just 2x plus 3, that's okay. Right hand side squared requires complete square formula. Just a squared plus b squared to get this 4 and then x plus 2 is not enough. We need one more step. So is it going better? Actually, we did have a little bit of improvement. Originally we had 2 square root. Now we are down to only 1 square root. So if we do this again, then you can isolate that square root and then get the problem done. Ready? Okay, let's continue working on it. 2x plus 3 is equal to, let's simplify this. X plus 2 plus 4 is at 6 plus 4 square root of x plus 2. That's what we have so far. And then the key was isolate the radical and take the power. So that's what we will do. I'm going to flip these to the other side. 2x plus 3 and then subtract these away. Again, I clicked the wrong key. Please note that I flipped this to the other side, and then that part stays. Alright, still going. X minus 3, because 2x minus x, 3 minus 6, and that's equal to 4 square root of x plus 2. And finally, I'm ready to take the square of both sides. Let's do it. This square, x squared minus 6x plus 9. I use complete square formula instead of foiling it. I could do x minus 3, x minus 3, x minus 3 and foil it up. But instead, I decided to do it this way. Complete square formula. Everybody should memorize this and be able to use it by heart because it appears so many times. A squared and minus twice, so 2 times 3 times x, and then 3 squared. You can foil it if you want to. It'll slow down a little bit. Go to right hand side. Let's see. 4 squared, that's 16, and then square root, square finally canceling each other out. Great. Finally, the square root is gone. Okay, let's go ahead. X squared minus 6x plus 9 equal to 16x plus 32 after breaking up parentheses. X squared minus 6x flipping over negative 16x plus 9 minus 32 equal to 0. Flipping everything to the left hand side. X squared minus 32x and then 32 minus 9, so it is 23. No, 20. Yes, that is that's 23. And this is not promising. Oh boy, I must have made some mistake somewhere. Just a moment, please. Okay, I found my mistake. Minus 6 minus 16 is not negative 32, it's 22. So it can be factored. X minus 23, x plus 1 equal to 0. Therefore, we have x equals to 23 or x equals to 1. We get that. Looks like we have two solutions, x equals 23 and then x equals to 1. But then again, eyes can be deceiving because you see, radical equation change into green equation and we get solution. But not all solution here in green is the solution from this radical equation. So you have to go back and check. So if you plug in x equals 23, what do you get? 2 times 23 plus 3 minus square root of 23 plus 2 equals to 2. Is this true? Let's see, 2 times 23, that's 46. 46 plus 3, so that's 49. Minus square root of 23 plus 2, that's 25, equals to 2, so that is 7 minus 5 is equal to 2. That's okay. So this is good. This is a solution. That solution. How about the other one? X equals to 1, then 2 times 1 plus 3 minus square root of 1 plus 2 equals to 2. How about that? I just plug in x equals to 1 here. So this is 2 plus 3, that's square root of 5 minus square root of 3 is equal to 2. Oh, okay, and this should be negative 1. X plus 1 is equal to 0. Yes, okay, at least it made some sense, but I don't think this will turn out to be true in any case. So 3 minus 2, so this is 1, and 2 minus 1, so 1. So what do you have? 0 is equal to 2. No. So this is not a solution. X equals to 23 is. So we can complete like this. Oh boy. This is normal for radical equation, as a matter of fact. And as I said earlier, this is not for everybody. And I have written some radical question from in exams before, but oh well, okay, I'll stop here.